This is our review for the quiz on rational expressions. So remember this unit, we have a quiz and then a test. So this is our first quiz on rational, which is just a big word for fractions that involve polynomials. So what we've done so far in this unit, simplifying rational expressions, okay, rules of exponents, factoring, those are all things that you need for this. Identifying the exclusions. The big thing is to look and see where is the denominator 0. That's my exclusion because you cannot divide by 0. And then the exclusion is going to take two different flavors. If the exclusion after all your simplification remains there in your final answer after you've simplified, then that is a vertical asymptote at that point. If in the course of simplifying that exclusion gets removed, we will say that that is a hole in the graph. Okay? And then we'll do more with this in subsequent math classes, but that's just what we're introducing here for the time being. After we did simplifying, multiplying, and dividing rational expressions, we move into adding and subtracting rational expressions. That's really it's akin to adding and subtracting fractions, which means you need to know how to find a common denominator. And again, using factoring in all of your addition and subtraction of rational expressions and simplifying complex fractions. So factoring is the big skill that has to be here for a lot of things that go on in this particular unit. So let's take a look. Simplify the expression. First thing I have to do, I have to factor this completely. Numerator and the denominator. So if I look at the numerator, I need to find two numbers that multiply to 15 and add to 8. So those numbers would be 3 and 5. So that tells me how I'm going to factor the numerator. So that's going to be factored as x plus 3 divided by x plus 5. Now to factor the denominator, I need two numbers that multiply to give me a 15 and add to give me a 13. So in this case, back up, that was a mistake. These two numbers do not multiply to 15. These numbers multiply to 2 times 15. So it's two numbers that multiply to 30 and add to 13. Those numbers are 3 and 10. So this is going to be, what, 2x squared plus 3x plus 10x plus 15. Factor by grouping. X times 2x plus 3 plus 5 times 2x plus 3. So this is x plus 5 times 2x plus 3. So the denominator of my original expression is x plus 5 times 2x plus 3. What are my exclusions? I look at the denominator. X cannot be equal to negative 5 or negative 3/2. Now, when I look at simplifying this, I can look at this and recognize that x plus 5 divided by x plus 5, that is simply 1. So the simplified expression is x plus 3 over 2x plus 3. Even though they did not ask it, this tells me that in my final answer, there is a vertical asymptote at x equal negative 3/2. There is a hole in the graph at x equal negative 5. Okay? Continuing on, very similar. Simplify the following expression. The key to simplification is factoring. Denominator and numerator completely factored. So this is x squared minus 4 times x squared plus 4 divided by, when I look at the denominator, numbers that multiply to 6 and add to 5. Those numbers are 2 and 3. So this is x plus 2, x plus 3. Am I completely factored? No, I'm not. The numerator can be factored again. So this is x minus 2, x plus 2 times x squared plus 4 divided by x plus 2, x plus 3. Before I do any simplification, what are my exclusions? X cannot be negative 2 or negative 3. Now to simplify, I look and see that x plus 2 divided by x plus 2, that is 1. So this final answer is x minus 2 times x squared plus 4 divided by x plus 3. Problem number 3, I see a division. First step in a division problem, turn it into multiplication. So this is x squared plus 10x plus 21 over x squared minus 9. Multiply, so I'm going to multiply by the reciprocal. So it's x minus 7 over x plus 7. Now completely factor. Numbers that multiply to 21 and add to 10. Those are 7 and 3. So this is x plus 7, x plus 3, x squared minus 9. That is x minus 3, x plus 3 times x minus 7 over x plus 7. What are my exclusions? X cannot be 3, negative 3, or negative 7. Now, can I simplify? X plus 7 divided by x plus 7, that is 1. X plus 3 over x plus 3, that is 1. My final answer is x minus 7 divided by x minus 3. Similar problem, division again. So doing this division, first step, turn it into multiplication. So x plus 5 over, if I look at x squared minus 25, that is x minus 5 times x plus 5. And I try to get in the habit of using parentheses a lot with rational expressions. It sort of overemphasizes that I've got everything completely factored. So multiplying, I'm going to flip the next fraction. That is x minus 5 over x plus 4. What are my exclusions? X cannot be plus or minus 5 or negative 4. Now, if I simplify, x minus 5 divided by x minus 5, that's 1. X plus 5 over x plus 5, that is 1. This is simply 1 over x plus 4. Okay, that tells me that that is a vertical asymptote, and plus or minus 5, those two are holes in the graph. Okay. Next problem. Perform the operation and simplify. So everything has to be completely factored in order to simplify. X squared minus 4, that's x minus 2, x plus 2. X squared minus 9, difference of squares, x minus 3, x plus 3. Multiply by, let's do the easy one, let's do the denominator. Two numbers that multiply to negative 6 and add to 1. That would be a 3 and a 2, so x plus 3, x minus 2. And then for the numerator, I'm looking for two numbers that multiply to give me 6 and add to give me 7. That's 6 and 1. So that is 2x squared plus 6x plus x plus 3. Factor by grouping. So 2x, x plus 3 plus x plus 3. This is simply 2x plus 1 times x plus 3. So that is the numerator here, 2x plus 1 times x plus 3. I am completely factored. Now I can tell all my exclusions. My exclusions, x cannot be negative 3, positive 3, and positive 2. Now, are there any simplifications that can occur? I see, what is it? X plus 3 over X plus 3, that is 1, okay? And then if I look and see, that is it, okay? So some people want to try to make more things cancel. That's all that's going to happen here. So, sorry, one more. X minus 2 over X minus 2. That's why I take my time. That is 1 as well. That's it. So this is X plus 2 times 2X plus 1 divided by X minus 3, X plus 3. Okay. You could multiply those back out, but we don't need to. I mean, that's fine to leave your answer like this. Next one here. So completely factored. If I look at it, I've got some factoring already going on. Look at 2x plus 1. So 2x plus 1. Okay. And then 3x plus 3. That is 3 times x plus 1. I factored out the greatest common factor. Now look at the denominator, x squared minus 1. That's x minus 1, x plus 1, times x minus 4, times x minus 1 over x. Now, are there any things that can be simplified? Well, x plus 1 divided by x plus 1, that is 1. X minus 1 over x minus 1, that is 1. So I am left with 3 times 2x plus 1 divided by x times x minus 4. Okay. Now, what were my original exclusions? So my original exclusions, where x cannot be what? 1, -1, 4, and 0. What are the ones that remain in my final answer? In my final answer, 0 and 4. So there will be vertical asymptotes at 0 and 4. So holes in the graph will be those exclusions that went away. So x equal plus or minus 1, those will be holes in the graph, or places where the domain does not exist for this function. Now we're moving into adding expressions. So the big thing here is you have to have a common denominator, and you have to have things factored as well. So let's look at this. Negative 3x minus 7 divided by, how do I factor that? Numbers that multiply to 2 and add to 3, that's a 2 and a 1. So x plus 2, x plus 1. Okay, and that's what? X squared plus 3x plus 2. So plus 4 times x plus 1. So it looks like my common denominator is going to be x plus 2 times x plus 1. So I need to multiply this fraction by 1 in the form of x plus 2 over x plus 2. If I do that, then I will have a common denominator. So let's do that. So I'm going to have negative 3x minus 7 over x plus 2, x plus 1, plus 4 times x plus 2 over x plus 1, x plus 2. Denominators are the same. I can add the numerators. So I'm going to get negative 3x minus 7 plus 4x plus 8 divided by x plus 1, x plus 2. On the top of that fraction, 4x minus 3x, that is x. And 8 minus 7, that is 1. So I've got x plus 1 over x plus 1, x plus 2. Now I see that x plus 1 divided by x plus 1, that is simply 1. My final answer, 1 over x plus 2. Number 8, similar process. I'm subtracting instead of adding. The key is to factor, find a common denominator. So I've got x. When I look at that first denominator, it looks like I can factor a 3. So 3x minus 5 minus, when I look at the next fraction, I can factor out a 2. So that's 2x plus 1. And then can I factor x squared minus 4x minus 5? Are there numbers that multiply to negative 5 and add to negative 4? That's a negative 5 and a positive 1. So this is x minus 5 and x plus 1. So what is my common denominator? My common denominator will be 3x minus 5, x plus 1. That is my common denominator. So it needs that I need to do a couple multiplications. So x over 3, x minus 5. This will need to be multiplied by x plus 1 over x plus 1. And then subtract 2x plus 1 over x minus 5, x plus 1. This will need to be multiplied by 3 over 3. That will give me the common denominator of 3x minus 5, x plus 1. So if I come over here, on the top I'm going to have x times x plus 1 minus 2, x plus 1 times 3. That's the numerator. The denominator is 3x minus 5, x plus 1. Now the goal is just to simplify with algebra. Don't make mistakes. So x times x plus 1, that's x squared plus x. And then this looks like minus, and that's going to be 6x minus 6. All of that over 3. X minus 5, x plus 1. So this is x squared minus 5x minus 6 divided by 3. X minus 5, x plus 1. Can I factor s squared minus 5x minus 6? Are there numbers that multiply to negative 6 and add to negative 5? Those numbers would be negative 6, positive 1. So this becomes x minus 6, x plus 1 over 3. X minus 5, x plus 1. Well, if I simplify this, x plus 1 divided by x plus 1 is 1. So this final answer, after all of this work, is x minus 6 over 3, x minus 5. Okay? A lot of work, a lot of factoring, a lot of arithmetic, and a lot of places where algebra mistakes can be made, but you guys are above that. Couple more and we are done with this review. So now we're moving into complex or mixed fractions. This is where it got a little bit more involved, but you just have to stay organized about what's going on here. Here I've got 2 fractions in the numerator and 2 fractions in the denominator. So really what you want to look at is if I covered all of this, let me back up. Let's just say, for example, if I covered all of that up, okay? That's a problem like I just did, subtracting fractions. Now you've got 2 of those problems, one on top of the other. So I just really break it up. Let's look at the numerator. What must I do in the numerator? So in this particular problem, I've got 3 divided by x minus 3, subtract 2, factor this. X squared minus 9, that's x minus 3, x plus 3, okay? So I am going to need to combine those 2 fractions. What's going to happen in the bottom of the fraction? Similar thing, 3 over x plus 3 plus 1 over x minus 3, okay? So in order to make everything combine, my common denominator is going to be x plus 3, x minus 3. So you can see on the top of this fraction, if I do this, multiply that first term by x plus 3 or x plus 3, I get a common denominator. In the bottom of the fraction, this needs to I need to multiply by x minus 3 over x minus 3, and then multiply here by x plus 3, x plus 3. If I do this, I will get a common denominator in the top and the bottom. And what's lucky for me here, it's the same common denominator in both, so that's going to give me some nice cancellation. Okay, so let's do the top. So I'm going to have 3 times x plus 3 minus 2, all of that divided by x plus 3, x minus 3. That's the top fraction. And on the bottom, I get 3 x minus 3 plus x plus 3, all of that over x plus 3, x minus 3. Now I have, if you look at it, I've got fraction over fraction, okay? Whereas I didn't have that before. Before, the original problem, I've got a fraction minus a fraction, okay? Once you get it to fraction over fraction, you can do further simplification. So let's just go ahead and expand the numerator. So in both cases, I'm going to get what 3x plus 9, 3x plus 9 minus 2 over x plus 3, x minus 3. All of that is divided by 3x minus 9 plus x plus 3 over x plus 3, x minus 3. Okay, so fraction over dividing by the fraction is the same as multiplying by the reciprocal. So if I look at this first expression, 3x plus 9 minus 2, that is 3x plus 7. So 3x plus 7 over x plus 3, x minus 3. Now, instead of dividing by what you see there, I'm going to multiply by the reciprocal. So multiply by x plus 3, x minus 3. And if I look at this highlighted in yellow right here, that is what, 4x minus 6. So 4x minus 6. So now if I look at it, I get simplification that x plus 3 over x plus 3 is 1. X minus 3 over x minus 3 is 1. My answer is 3x plus 7 over 4x minus 6. Now I can just check and see it's not completely factored on the denominator. 3x plus 7. If I factor out a 2, I get 2x minus 3. Okay. Either of these answers would be good, but there's no further simplification from there. So a lot of arithmetic, common denominators, simplifying, factoring, and you got to keep a lot straight to make sure you can get there with no mistakes. Final problem. Perform and simplify the following mixed fraction. So again, I've got 2 fractions in the numerator, 2 fractions in the denominator. So it's really like a double problem. So if I write this out, I've got 3 over x minus 1 okay. It looks like the common denominator is going to be 5 times x minus 1. So if I multiply this expression by 5 over 5, that gives me the common denominator. Multiply the 3/5 by x minus 1 over x minus 1. On the bottom, if I multiply the 3/5 by x minus 1 over x minus 1, and multiply the x plus 2 over x minus 1 by 5 over 5. When I do this, every place you see has the same denominator, 5 times x minus 1. So it's just a matter now of staying organized. So this is going to be 15. minus 3x plus 3 over 5x minus 1 divided by, and I'm going to get 3x minus 3 plus 5x plus 10 over 5 times x minus 1. So I get, what is this, 18 minus 3x over 5 times x minus 1. And instead of dividing by this fraction that you see here, I can multiply by its reciprocal. So that's 5x minus 1. And what do I see? 8x plus 7. Now I see that 5 divided by 5 is 1. X minus 1 over x minus 1 is 1. So this is 18 minus 3x over 8x plus 7. That's a perfectly good answer. I can factor the numerator. It's really not going to make a substantial difference because if I factor out a 3, I'm going to get 3 and 6 minus x over 8x plus 7. Either way, there's no further simplification that can happen. So either one of those answers would have been good for a final answer. So again, the big key things here are factoring, simplifying, and exponents, making sure that you're very picky with your signs, you're distributing, and finding least common multiples and for adding and subtracting fractions. Okay, that's it.